For the longest time, I've been very interested and curious about how we define information at a neurological as well as cellular level. When you look at other sciences, let's say computer science or physics for that matter, definition of information is not as blurry. It's, for example, in computer science, you say zeros and ones, a bit is made up of that, and that is how you define information and how computer, for example, exchange information back and forth. But when it comes to the biology, more specifically neurological level, those type of definition kind of don't follow the same clarity, if you will, and they become much more blurry. And for us to be able to define what information is, in my opinion, is extremely important, because essentially everything is information. Even in other sciences than neuroscience, let's say in physics, the definition of bits of information is also evolving. For example, in classical physics, a classical bit of information is this zeros and ones still, or how you look at information from the classical physics point of view. But most recently, you also have the quantum physics, where the notion of quantum bits is introduced. So you have then the classical bit of information, but now you also have the quantum bit of information. And one of the major differences between a quantum bit versus a classical bit is, if you take an example, a spin of an electron. In the spin of an electron, you have a lot of different information. It's not only whether it's going forward or backward. You have the direction of the electron, and if there are any magnetic fields around it that affects the movement of the electron, etc. Now, I'm a neuroscientist, I'm not a physicist, so my information regarding this particular subject is very limited, but regarding the quantum bits, at least at an eagle eye view, that's what I've learned from the quantum physics. And so therefore the quantum bit, it's more like a vector-like of information rather than bits of information. Obviously, we're really simplifying the world of quantum physics and neuroscience just for the sake of conversation here, but the truth of the matter is that the definition of information at the neurological level is extremely important, because that is one of the biggest enigma, and I'm still not convinced whether we can really define it. We still have ways to go to understand it, but now the question becomes, have we been thinking wrongly about the exchange of information among neurons, thinking of it from the classical bit? Should we now thinking of it from the quantum bit instead? I personally have not seen any talks around that. If you have, please let me know. But I do refer to one. And that talk is when Leonard Suskind also talked about, obviously, quantum bit, because that is his field. But at one point, I heard there was one interview that he had where he did mention a potential connection between neuroscience and, in this case, the quantum bits. Having said that, this is still a very young type of a way of looking at science. And with young, I mean, it's really in its infancy. We still have ways to go, but I would like to think of other ways that we could potentially explain the exchange of information within neurons, because if you think of it just from a simplified version of bits, neurons are, because we don't only have the neurons, but we also have the neural oscillations to think about when this exchange of information happens. within the brain and without the brain, outside of the brain, because it's still waves of information, and within those waves there are still electrons, at least to the extent that we know of the neural oscillation to be happening today, because at the end of the day, whatever information flows in space between you and I, it's still at a particle level. It is at an electron and particle level. And so, in my opinion, those two are connected. I personally hope that I can figure that out before I die. I'm at least hopeful around that, but I am not as convinced anymore whether we can actually figure that out based on the technology that we have. I don't think we're there. I think that potentially we'll need to use mathematics to get there, like they do in quantum physics, because that's basically, it's all about most of the theories, it's all at a mathematical level. The technology is still not there for us to actually do those experiments, but at least that's my hope, to somehow make that connection at a theoretical level, at least until I am still living on this earth, because it's just so complicated. So but we're hopeful. So thanks for watching. See you next time.